For today's lesson, we're going to learn how to draw a line given its equation in the form y equals mx plus b. I'm going to learn that horizontal lines that are flat and vertical lines that are straight up and down have special equations and we're going to learn how to draw those graphs. And I'm learning about what x and y intercepts of a line are. So at the beginning of the learning, we were talking about a Cartesian plane. And we were talking about how this is all these are just units of 1 to the right, to the left, to the up and down. And we've learned that when we have an equation y equals mx plus b, m is the slope and the b is the y-intercept of the line. This information can be used accurately to draw a line of that line on this. And by just identifying the components of your equation, you can sketch those lines really easy. But it's important to identify which is which. So if I have a slope, my m is 3. Well, when we were talking about slope, that talks about rise over run. So if we have a slope that is a whole number or an integer, we need to make it a rational number or a fraction. By doing so, we can just put it over 1. And this tells us our rise of 3 for a run of 1 is going to create our line. The y-intercept tells us where to start on the y-axis. So if I'm looking at a y-intercept of 7, this is our starting point. 1, 2, 3, 4, 5, 6, 7. There's our y-intercept. And then I can use my slope to find more points. And by doing so, I can just follow the pathway of a rise of 3, run of 1. And our run is always going to be to the right. So I can go right 1, up 3, 1, 2, 3. Over 1, 1, 2, well, it'll be somewhere up there. And we know that this has to be a line. So a line means it's got to have, we can go backwards by using the same pattern. And all these dots form a straight line, following the point of slope of run of 1, rise of 3, over 1, up 3, over 1, up 3, and then I can just use my ruler to connect the dots. Now you're going to say, well, do I need to make all those dots? No, but it helps me to understand the pattern of slope and a y-intercept. And that slope continues all the way. So that is kind of the basic idea when graphing any straight line. You plot the y-intercept first, and we use the slope to find more points. As we learn through this, we're also going to be able to say, here's my line, can I make my equation? And we've learned that already, and we'll continue to learn that. All right. Our second example here, what I want you to do is push pause, and I want you to identify what your slope and what your y-intercept is. Push pause and write that down. So hopefully you wrote down that my slope is -2 over 3 and my y-intercept is 2. Well, the y-intercept of 2, I know that I'm going up there 2, there's my y-intercept of 2. Now we can use our rise over run. Well, if this one's always going to be going right 3, well, this whole fraction is negative. So we know that this line, when we graph it, is going to have a negative slope. So it's going to be somewhere in that area. And be able to see this, I can say if it's a -2 or a negative number on top, this is, I'm going to go down. All right, so when I plot my points, all right, I'm going to go, I can go down to right 3, make a point, down to right 3. All right, those dotted lines in there just to show you kind of the pathway I'm taking. All right, and I can continue the path the other way. All right, so that the image is mirrored. There we go. So now I can just connect the dots. There's my equation. So I have my slope down to around a 3. There's my slope in action. All right. But this is key. All right. Plot your y-intercept first, and then use to find more points. All right. So that is the basic idea for today's lesson. Is I can sketch that line, and by understanding where the y-intercept is and where the slope is being created, find more points. All right. Well, last little example here. Well, take 30 seconds. Hit pause. Tell me what your slope and y-intercept is for this equation of y equals 1/4 x. Hit pause, give it a try. So hopefully you said that the slope was 1/4 and the y-intercept was 0. Well, if I'm looking at my equation here, okay, there's my m, this is attached to x, it's multiplying by x, yep. But here it's like an imaginary 0 for the y-intercept. Right? So it means I don't have any initial value. Okay? So what I want you to do now is push pause and see if you can graph my line with a slope of 1/4. Push pause, give it a try. Hopefully when you graphed your line, you said you had a rise of 1. So I've got a rise of 1, and I run a 4. So I ran 4, up 1, ran 4, up 1. And then I can repeat the pattern and going backwards. So the equation of this line is that. So that's kind of the basic things that allows us to graph these lines nicely. Find your y-intercept, plot it, take your rise over your run, make new points, draw a line. All right. So there's our success criteria. Just exactly what I just said before. Plot the y-intercept, use the slope to plot more points on the line until you fill the graph space. And the only thing I forgot to do was have arrows here. And those arrows tell us that the line goes on forever this way and goes on forever that way. We used a ruler to draw lines. All right. If there's more than one line on the same set, make sure you label your graph. Okay. So what I want you to do is push pause, go ahead, graph that line, and compare with my answer after you hit pause and you've graphed it yourself. So hopefully when you graph this line, that is the way the graph looks. Remember, this slope is negative, so that means I had to go down for my y-intercept 5 and then right 3, and I follow the same pattern. If you're a person that needs to use these dotted lines to count, that is totally fine as well, but that helps you to kind of visualize what that means. So that's kind of the basic idea of today's lesson. All right. Now there's some special cases. And we all have special occasions where we have a flat line where the slope is 0. All right. So if I was looking at this equation y equals 3, that's kind of the same way of saying mx plus 3. Well, if I wanted to make this 0 go away, it would have to be like this. All right. I have a slope of 0. All right. That means for every rise I go of 0, I'm going to run 1. That's way of saying it. So if I start off at 3, 1, 2, 3, there's my 3. All right. I'm going over this way. All right. So run 1 unit right, up, nothing. So I stay there. Another run right, another run right, move on. Okay. Y equals 3. Now, there are other ways of looking at this. And if I was looking at a table of values of x and y, if I was looking at all these, that point right there is 0, 3. This point right here is 1, 3. This point here is 2, 3. And if I keep going like this, these are the points where y equals 3. So that's another way of kind of visualizing why this is where everywhere y equals 3. And if you don't believe yourself, use Desmos and plot y equals 3 on your graph. And that goes with the other ones as well. So if you want to see a visualization of it, give that a go. Okay. Here, my slope is 0. No slope. The other one is where I'm doing a vertical line. And we can have vertical lines, but there are very special cases for that. And as you learn math throughout, these will be some special cases. And what I'm going to do is in this case, the slope is undefined or infinite. And if I was thinking about that, if I was skiing down this slope, I'd be going up pretty fast. I would be going faster and faster and faster. But once I got vertical, I'm going straight down. I'm not making any runs as well. I'm going straight up and down. So that's kind of the reason where that is the case. Now, another way of looking at that is if I was thinking about points. And if I'm looking at points where x equals -3, right? And there's going to be infinite amount of these because we can have infinite number of y's. If I was looking at density that we talked about at the beginning of the year. All right. So if I had at y equals 0, x equals -3, that's where that point is plotted. If I did -3, 2, that would be that point. -3, 4 is at that point. And I can have numbers in between. Likewise, I don't know, I'm going to choose different numbers. So let's see if I do 3 and -5. Doesn't matter the pattern. All right. But again, there is my line. All right. So that line, x equals -3, passes through the x-intercept. It goes through that. And this line tells us that there's infinite number of points that I could plot there to get that answer. So hopefully that helps with that. Think about going through x with that number, and back up here I went through y of that number. That's another way of thinking about it. Alright, find the point of intersection of lines x equals -2 and y equals 3. So what I want you to do is take 30 seconds, based on what we just did up there, see if you can plot those two lines. Alright, I'm going to hit pause and we'll see if it makes sense. Alright, so here's my first line, x equals -2, because I know it goes through x on the x-axis at -2, so all these ones are there. Here's my line y equals 1, because at y equals 1, it goes through all these values of y equals 1 going through there. And the last thing it tells us, what's the point of intersection? All right. So I can look at this and say, well, what's the value of x? That's -2. The value point of y is 1. So if I'm looking at that, the point of intersection is the point where x equals -2, y equals 1. Is that coincidence? No, it will work that way all the time. Because this is where x is equal to -2. This is where y equals 1. And where they meet is the location on the grid at -2, 1. So it's kind of interesting that way. So just so that we know that if I'm looking at some special cases, all right, where I'm dealing with y equals 3 is always horizontal, x equals -3, or x equals any number is going to be vertical, and we move forward. But the biggest thing here is, if I have it in this form, I should be able to follow the success criteria to practice my learning. All right, so you can go ahead and practice the learning. If for some reason you don't feel 100% comfortable with doing these, use Desmos to check your answer for that. So you can plot that into Desmos graphing calculator, plot it, and it should match exactly what you have in your graph. So give that a go, and we'll talk soon.